Hi everyone, as Ben said, I'm Christian Elmerot. I do authoritative DNS as part of a team at Cloudflare. So you want to do your domain migration in between two different providers. And assuming you've set up everything at both providers in terms of your zone data, then for unsigned zone, that's a fairly easy process. You update the DNS record at the registrar parent, and basically you're done. But when it comes to signed zones, things become a bit more complicated. For the longest time, the advice to customers out there was basically, you go unsigned, wait a bit, update the DNS set as the zone is now effectively unsigned, and then you re-sign again. But when you don't want to go through that process of unsigning your zone for various reasons, policy reasons for instance, then everything depends upon who holds the keys to the castle. And now when I talk about who holds the keys, I'm talking about the KSK for a zone. If you as the domain owner holds the key, then most of the time it's basically updating the name server record set, because you're usually transferring in between the different providers using secondary DNS. And this is where you're using pre-signing. For other scenarios though, you hold the key, but you want to use like a live signing solution such as Cloudflare's, where we, the provider, holds the ZSK, you're basically going into multi-sign the DNSSEC for the zone. If, on the other hand, the provider holds the keys, then one could potentially talk about exporting the keys and importing them at the new provider and update DNS. But most of the time, that's simply not an option because the keys are in an HSM. And also, exchanging cryptographic material is not something you want to do lightly for security purposes and potentially policy reasons as well. So you're looking at basically doing multi-signer DNSSEC. And the different models of multi-signer DNSSEC is you can find in RFC 8901. However, transferring a top-level domain such as .gov in between two different providers, you can often run into additional considerations that are required to take into account. We were migrating the registry and related functionality to the registry. We were doing the name server transition, and we were also doing the DNSSEC transition. And for a top-level domain, due to the nature of DNS and how DNSSEC works, where you have the root, top-level domains, and the delegations, going unsigned is not really a realistic option. So, where a second-level domain or further down the tree, you can usually force through a transition. On a technical level, with little to no issues, you can simply update it at the registrar. For a TLD, which holds the potential to disrupt all the delegated domains unless you do it with consideration and in coordination between the different providers, and good coordination requires a good cooperation. So that leaves us with basically doing a multi-signer DNSSEC transition for a TLD. And the actual migration itself is transitioning the zone into a multi-signer state. And once you're done with that, you're basically doing this thing in reverse. And what that means is, in short steps, you add the incoming provider's DNS keys to the set. You add the incoming provider's DS records to the parent, in this case the root. And then you have a period of joint operation that can be short or extended depending on how you then switch the name server sets. If you basically decide to flip the name server sets from the incoming providers to the outgoing, from the outgoing providers to the incoming providers, then you are looking at a fairly short joint operation period. But if you're adding the incoming providers to the outgoing provider set, then you can basically schedule for how long this joint operation is supposed to happen. And then transitioning out to single signer state is basically doing this operation in reverse. Remove the outgoing provider's NS, DS, and DNS keys. Except, usually this requires both providers to use the same DNSSEC configuration. And going into this process, Verisign at the time used algorithm 8 with NSEC3 for the zone, whereas Cloudflare, we generally use algorithm 13, live signing, and NSEC with compact analog existence. And that's not a single parameter in common. So really we needed to come up with a realistic proposal that we could put forth for how we could do this transition. And we had a few options at the table. It was suggested that we just, let's do it live, roll the algorithm and use NSEC and NSEC3 in combination during the transition. Another option would be then to switch the GOV zone to use NSEC3 prior to the migration and do the actual algorithm roll during the transition. Switch GOV to algorithm 13 prior to the migration, use NSEC3 and NSEC and NSEC3 in combination during the transition, or switch GOV to algorithm 13 and NSEC3 prior to migration. And that would fully match the DNSSEC configuration then. Or we, Cloudflare, would implement live signing using algorithm 8 and do that, and then also add support for NSEC3. Least amount of work would, of course, been to use option 1, do the algorithm roll, use dual use of NSEC and NSEC3 during the transition. But the question then, of course, arose, would the GOV zone still resolve during the transition if that was the way we choose? And we knew in order to fully realize if this was a valid scenario, we had to do some testing. So we decided to test using dual providers with different algorithms, algorithm 8 and 13, with different denial of existence methods, NSEC and NSEC3. But also separately test dual provider using the same algorithm and NSEC and NSEC3 at the same time. So similar to what Shane described for his tests, we were using RIPE Atlas probe measurements. I won't go into details of the RIPE Atlas platform, but it's excellent for these kinds of things where you want to see how the real world behavior. One thing to note, though, is that there is always a small amount of background noise in RIPE Atlas measurements because of things just happen in the real world. And some probes have misconfigured resolvers, etc. So it's important to establish where the current baseline lies in terms of failure rates. And we established the baseline using DNSSEC OK disabled. So for the results where we were looking at the algorithm roll during the transition together with NSEC and NSEC3, the test we performed, I won't go into the details, but we did quite a large set of tests. We tested positive answers on the delegated zones. We tested no data answers, NX domain lookups, and where each provider either uses 8 or 13 to sign. And we saw a serve fail rate of about 0.5%, where the baseline was 0.07% instead. But the number of probes with complete failures, where all the configured resolvers were serve failing, were higher than in the other setups. And the interesting thing is here, what was actually failing? So we decided to look closer into the serve failure results. And it turns out my very own probe, which I have at home, was one of the failing ones. Slightly embarrassing, but On the other hand, since I fully control the resolvers, that's very good for debugging. At the time, I was using Unbound with the configuration option harden algorithm downgrade enable, and it turns out that this will serve fail when RSIGs for all configured DNS key algorithms are not present in the response. And this is all in RFC compliance, which state that the signatures must be present. And turns out that a bit too many resolvers use this configuration, so algorithm role during the transition was basically out as an option because of this. Now, looking at the combined NSEC NSEC3 results, we saw serve fail results of slightly higher than the baseline, but very few probes, on the other hand, they fail to resolve. Very few probes fail on all the resolvers. And this in combination with only negative answers seeing an impact would to us indicated that this was a valid configuration to use during the transition. At the same time, Verisign, as we proposed this, wanted to do their own set of tests, and attached at the end of this slide deck is a short, brief statement on the test that Verisign did for this. And I would encourage any questions of what Verisign did for this to Dwayne Vessels of Verisign, who did a very nice set of tests there. So we finally agreed upon having a DNSSEC configuration that was usable during the transition. Cloudflare would implement live signing using algorithm 8, pushing the algorithm rollover until after the transition was completed. We would use NSEC and NSEC3, each provided on their own at the same time. And this is a configuration that is also supported by the multi-signer RFC, which says, since authenticated denial responses are self-contained, NSEC and NSEC3 can be used by different providers to serve the same zone. And in November, the transition was successfully completed. We, to our knowledge, have heard of no reported issues during the multi-signer stage of the transition. And this is the first time that we have heard of a domain of this significance being transitioned using NSEC and NSEC3. The successful completion of this transition was thanks to the testing, cooperation, and coordination of Verisign, Cloudflare teams together with the domain owner of CISA. So today, the Gov zone is fully served by Cloudflare's platform using live signing with algorithm 8 and the NSEC compact denial of existence. And we plan to roll the algorithm from 8 to 13 quite soon. So, too long didn't read. NSEC3, together with NSEC, is during domain transition works very well and was successfully tested used and tested during the GOV TLD transition. And that means that it's also a valid configuration to use in production for any zone that wants to use it, not just during a transition phase. Rolling algorithms during the domain transition needs a bit of community work. We need an RFC update to say that we mustn't require all the RSIGs to be, for all the algorithms to be present. And as long as an answer can be validated for one of the supported algorithms all the way through. And this is also vital to improve multi-sign operations where we someday might arrive where a zone is served by two different providers, each using their own algorithms and DNSSEC configurations. And with that, I open up for questions.
Hello, Wes Hardiger, USC ISI, the ICANN board, and definitely not speaking for either one of them because they won't like what I have to say. So I've looked at this problem a lot, and I actually published a draft about another way to do it that I don't think was in your bullet list, and I just want to know if you considered it, which is going insecure for a day or something in the process, knowing that OMB would not be happy with that, right? One of the argument that I put into the draft is sometimes you have to debate operational stability over a very short down window where, things could go wrong. Did you consider that at all, or?
It was brought up during the early discussions, but we said it would basically be a failure of us if we couldn't complete this in a signed manner. Shimon?
Hi, I'll remember to introduce myself this time. I'm Shimon from Salesforce. So I'm glad that you are able to very publicly show a successful multi-signer transition and also in particular the NSEC and NSEC3 coexistence with two signers on each side. Because I remember, I feel I have to say that as one of the primary instigators of the multi-signer protocol. I remember having discussions with Dwayne Wessels about whether it works, NSEC and NSEC3 together. And I said, and I assured him it works. And he says, you haven't proved it to me, you've only deployed it in a lab, but now you've shown it, so that's great. So the other question I have for you is, you did the algorithm roll to RSA. And did you notice any significant computational cost in doing so? Because it is much more burdensome, right, for an online signer.
You're absolutely right. We
Okay.
had a look at what it would cost in terms of CPU time to sign with algorithm 8. And it is depending on, it's very much depending on the key size for RSA as opposed to for algorithm 13. And it is more expensive than using algorithm 13, but not that much more expensive for the ZSK size that we were using during the transition, which was 1280 bits.
Okay. All right, great. And then on that topic, you mentioned that it would be good if these RFCs, the rules were relaxed to allow this kind of thing to operate without having to do, which in my view is an unnecessary algorithm roll. And I want to let you know, you may be aware already that a bunch of people, Dwayne Wessel, Peter Thomason, and I, are working on some proposed updates to the RFCs to relax these rules to allow that to happen. Thanks.
Hi, Ben Schwartz. So just on that last point, I just want to clarify, are you arguing to ban harden algo downgrade?
Not banning algo downgrade. I'm arguing for if you have a validated chain all the way through to the answer, then
Right.
that is not an algo downgrade.
I know, but harden algo downgrade, that flag implements exactly the behavior that I think you're saying you want to ban.
Yes.
Okay.
The way that flag is currently implemented, yes.
Okay, just checking. And my other question is, so there was a transition, leaving aside all of the DNSSEC questions more or less, there was a transition period here where this registry was being, or maybe it's not, is .gov a registry?
Sorry?
It's a registry. I assume it functions more or less as a registry.
It's a registry, yes.
And so how did you handle registrations during this transition period where the zone is being served by these two independent systems?
Basically, this was declared as by the registrar by the registry at the time to be a period where no changes could be made.
Okay, thank you.
Thank you very much.